The lovely lady in purple. I love it. Number 9, if you didn't hear, because the other numbers, when you add up the digits, they equal 7. Slepper. Jen Hornslep. All right. Deep thinking there. Lisa. 16 is the even number out of those 4.
I can't even get these things open.
These are the kind of tasks that are open-ended. They provide for flexible thinking. They provide for a variety of answers. They promote talk. So the kind of things that we're thinking about now are the kinds of open-ended activities that really help in your math instruction. So we hope that, so.
And I guess we're going to ask, obviously you're not giving us the right answer. And the kids are going to ask for what was the right answer because they want to know if they were right. So yeah. We can just tell them that all of those, as long as the explanation fits.
Absolutely. Absolutely. Right. Absolutely. Yeah.
And I think if I could add that it helps them to understand that sometimes there's more than one right answer or more than one way to solve a problem. And I certainly needed to learn that because I had it in my head that there was one answer. And I think it's really important for us to open our minds to the variety of ways we can solve problems and to the variety of possibilities that are out there. Lisa?
I know we're talking about math, but many times in the many years that I've been teaching, you read a story and there's a comprehension question. And a child looks like they have the wrong answer, but when they explain why, I'm like, you are right. And yet the book will tell you if it's A, B, C, D, it is not the right answer. But the child is right because they persuasively, they prove their point in explaining it. So the dilemma is sometimes, I know this is across the curriculum, sometimes the open mind, it is wonderful. But then we get these tests and assessments that we have to do with the kids, and you go home and you correct them, and the child's not there to explain their point, which is why we have to make them better writers to explain themselves. But there is a very fine line between, I mean, especially in reading. I mean, in math, we applaud all these wonderful ideas and that all the answers are right, but a lot of times, we've got these assessments and maybe they're not doing the children.
Well, I think you'll see as we go throughout the day, we're going to be talking a lot about discussions and about children being able to justify their answers. And certainly one of the practices that are in those 8 best practices, it talks about attending to precision. There are some things that aren't negotiable. 2 times 3 is 6. There's no way that we can change that or be persuaded that it's really 10. It really is 6. But it might be that it's 2 plus 2 plus 2 equals 6 or 4 plus 2 equals 6. There's different ways to get to the 6. And I think a lot of the, will be challenging you today is think about how you're thinking about your teaching, your assessments as we go forward. And it's not just math. I see a lot of this carrying over to all subject areas, but I think we're challenging you today to think about your thinking and think about your expectations for kids. And it's not going to be done at the end of the day. This is a process that we'll be going through in the next few years as we begin to implement the Common Core. But thank you for that comment.
So let's get, you might want to take a look at the bulleted list that is right underneath the cover sheet. Those are the 8 standards of mathematical practice. That's what ties us all together and tells us what mathematically proficient students do. And then I'm going to sort of toggle back and forth. I made the mistake, I believe a year ago, my staff will remember, we plodded through the paragraph explanation of make sense of problems and persevering in problem solving. And it's dense material. And when you begin to read these standards, you realize that no longer is it okay for our students to have some surface understanding and to memorize basic facts. We really want deep levels of understanding. And when you just even pull out the verbs that are used in the statements and the explanations, they are really high on the Bloom's level of taxonomy. We are asking our students to evaluate, to justify, to make conjectures, to explain. And those things happen with some time and some practice and some cultivating of those disciplines. So I'm going to kind of go through, and I know if you've looked at these quite a long time, it might be repetitive, but if you're looking at them for the very first time, which some of us are, I want to sort of go through them. I'm also going to share with you, if I go back and forth, I want to give credit to where credit's due. The Jordan School, and I'm not sure exactly where it is, but this is something that Jenny and Fred shared with us, have made posters of the standards in a bit more kid-friendly terms. And I will make this available to your principals if you want to reproduce the standards in this format. And it's a little dense for K through 2, but perhaps as you begin to incorporate these in your instruction, you might want to have them up in your classrooms, grades 3 through 5, or you might want to modify them too, to be able to continue to remind yourself that this is a big piece of your math instruction, and to anchor your students as their problem solving. So I know it's kind of dark, but making sense of problems and persevering in problem solving, we really want students to take a look at a problem and think about the entry point. Not just haphazardly throw together the numbers that are in the problem, but where thoughtfully should they start? Where should their answer be ranged between? What's the perhaps estimate? What are they really looking for? We want them to make some conjectures. We want them to think thoughtfully about their path that they're going to use to solve the problem. And then we want them to continue to reflect back to the situation. Are they using the right units of measurement? Are they in a path that's going to lead them to the correct answer? Asking that all-important question, does my answer make sense? Does it fit the situation? And can I check my work with a opposite operation or a counter example? So what they've asked, in a kid-friendly way, when presented with a problem, I can make a plan, I can carry out my plan, I can evaluate its success. And they sort of have broken it down into before and during and after. But I think that it's sort of a good way, and we spent a long time just sort of plodding through problems to get that sense of what it is to create a thoughtful plan. And to be quite honest, there were certain parts of the day back in Beverly, Massachusetts, that it's like, no, I don't want to think about another problem. And so living that, you can see that sometimes for your kids, that, there's going to be moments where you need to take a break and step back, and, after lunch, we'll come back to this. So, because the work is intense and the work is thoughtful. So, let's go back to the next one. Was to reason abstractly and quantitatively. And I think there's two words here that sort of make a big impact. Is that we want our students to read a problem and begin to decontextualize. Take the numbers in that problem, perhaps create a visual, perhaps create a picture, use a diagram, create an equation, and then put those numbers back into the problem, contextualize it, and say, this makes sense? Am I looking for a number of miles that I walked over 3 days? Is my unit of measurement correct? Am I talking about miles? Are they talking about inches or feet or meters? So those were the two big words. I think they should be actually switched on this poster, so there's a little bit of an error here because the student would decontextualize first and then perhaps put their information back into the problem. But I think it's a nice visual again for reason abstractly and quantitatively, that's hard for our elementary students to understand, and this puts it in a little bit more kid-friendly terms. The next one is to construct viable arguments and critique the reasoning of others. So even in kindergarten, we want students to share with us their answers and to show us why and to defend how they got there. So they really have to be able to verbally express themselves in a way that's understandable. And that's where our speech and language pathologists help us. And we're going to be eliciting more than just a telegraphic response from them. We're going to be continuing to say more, explain why. So we want students to make conjectures and to critique the math thinking of others, and that only comes for when they listen attentively to another student and piggyback their comment on what they've just heard, and that takes a level of practice, as you can imagine. I'm sure you have those students in your classroom that raise their hand and they have it up there, and you're saying, you know, I'm sure is this on topic? Is this something that we're talking about? Have you listened to your peers? Is it connecting with them? They're telling you yes, but what they come out with is so disparate that you realize it's something that just needs to be worked on. So can they construct, justify, and communicate arguments by considering the context, using examples and non-examples, using objects, drawings, and diagrams, and then I can listen attentively to my peers. I can think about what they have said, and, you know, at some level, can you agree, or you see some flawed logic in your peer, and you want to respectfully try to defend your position. That's a big respect. The next one is to model with mathematics. And that has to do with realizing that math impacts every day, every thing that we do. We live it, we need to use it. You calculated, you know, mileage here. We use it in the grocery store. We use it continuously. So it's a living and breathing kind of discipline that they're going to use and they're going to become very good at. So we want our students to be able to make assumptions, estimate, to begin to think about their answers. We want them to use appropriate tools. Do they need to draw a picture? Do they need to think about, and we'll get to it later, some of those other instructional tools that we use in our classrooms, and so we evaluate our answers and make changes if needed. But it's something that we're going to share with them that it's exciting. You're going to use this every day for a very long time, and we're putting into practice now what we'd like you to do. Next one. So we'll go here. It's to use appropriate tools strategically, and you introduce varying levels of visuals as well as instructional tools or manipulatives to help your students see and work with concrete, to go to the representational, to then go to the abstract. So it's important to expose them to the materials, but when to use them and when it's going to be appropriate to use a ruler, a graph, a diagram, an input-output chart, an open number line, a bar model, a clock model, a formula, a thermometer. So you want to make those available to them, and then to help them, assist them as to when it's appropriate to use them. We're up to attend to precision. What's great about math is that, yes, you have to be precise. It's helpful to use the correct vocabulary. It's helpful that